Math is radical. Now let's figure out how to simplify it. Simplifying radicals. Now what we're doing when we're simplifying radicals is we're making it easier to read. We're putting as little as possible under that square root sign. Let's take, for example, the square root of 25. Well, instead of leaving it square root of 25, we can rewrite that as the square root of 5 times 5, which can also be rewritten as the square root of 5 squared. Well, when I have something squared and I'm taking the square root of it, that is just the number itself, so that is just 5. Now we can also simplify if we have two numbers under the radical sign and they're multiplied times each other. We can take the square root of one times the square root of the other. So this is the same as the square root of 25 times 16 is the same as the square root of 25 times the square root of 16. And we're just going to look at this one example to see that it's true. Well, the square root of 25 times 16, 25 times 16 is 400. And that's equal to the square root of 25 times the square root of 16. I just rewrote that. And the square root of 400 is just 20 squared, and that's equal to 5 squared times 4 squared. Now when I have it written like this, I have something, square root of squared is just 20. Square root of 5 squared is just 5, and the square root of 4 squared is just 4. And 5 times 4 I know is 20, so for this case it works, and in fact in every case this will work. Here's something to be very careful of. Don't ever think this is the same thing as multiplication. When you have two numbers and they're added together under a square root sign, you cannot say that's the same thing as the square root of each of those numbers added together. So the square root of 25 plus 16 is not the same as, not ever the same as, the square root of 25 plus the square root of 16. And I'm just going to show you in this one example, this would be called a counter example, that it's not true. Well, 25 plus 16 is 41, and that is not equal to, not ever, equal to the square root of 5 squared, that's the same as 25, plus the square root of 4 squared. The square root of 41 is not equal to, the square root of 5 squared is just 5, and the square root of 4 squared is just 4, that's 9. And square root of 41, that's not even a natural number, so there's no way it's 9. But let's go ahead and do it on the calculator, and we'll check to see what about is if we round it. So that's about 6.4, and that is not equal to 9. So you can't take that square root sign and distribute it between the two terms you've got in there. If there's a plus sign in between there, you cannot do that, only if there's a multiplication sign in between. So now let's look at another example that doesn't work out. Let's start out with a really common example, the square root of 8. It looks like we should be able to take the square root of that, but it doesn't come up with a whole number. And so what we need to do is to break it down into its factors. So 8 is the same as 4 times 2. You could have put 2 times 4, the same as 4 times 2. I recognize that 4 is a perfect square, so I can rewrite this as the square root of 4 times the square root of 2. Now I know the square root of 4 is 2, so I have 2 times the square root of 2. And when we have something times a radical, we don't have to write that multiplication sign. It means the same as 2 square root of 2. So 2 square roots of 2, 2 times square root of 2. Well, now let's say I didn't recognize square root of 4 as a perfect square. I'm just going to continue to write down the factors so that 4 is the same as 2 times 2. So I have 2 times 2 times 2. These are all prime factors now. That's as far as I can go. And I can rewrite those 2's. If there's a squared one, that's really what I'm looking for because I'm taking the square root. I can rewrite 2 of those 2's as 2 squared times 2. Now I can rewrite that as the square root of 2 squared times the square root of 2. The square root of 2 squared is 2. I'm just undoing that squared. Times the square root of 2. Remember, that's the same as 2 square root of 2. So exactly the same thing. I just kept simplifying if I didn't recognize that perfect square in there. Now I have to admit, the saying 2's too many times does remind me of 2 2's. So after this 2-2 break, let's get back to it. So let's try a little bit bigger number. The square root of 125. Now that 5 right there tells me right away that 5 is going to be a factor. Anything that ends in a 5 or a 0, you can divide by 5. So I'm going to go ahead and do that division now. 5 into 12, 2, and that gives me a 25. And so I can rewrite that square root of 125 as the square root of 25 times 5, or 5 times 25. Now, by doing this, it's exactly the same thing. That's 125. Now let's say I see this 25 as 5 squared. And if I didn't, I could just divide 25 by 5 and still get 5 times 5. And now I can rewrite that as 2 square roots. The square root of 5 times the square root of 5 squared. And that gives me the square root of 5 times 5. The square root undoes that squared. Now, when I write this, I always write the non-radical part first. So I write 5 times the square root of 5 instead of square root of 5 times 5. That way my radical doesn't accidentally go over that other number. Let's look at a number like 231. Now, numbers that end in 1, people like to think of as prime. 231 is actually not a prime number, and we can see that by adding the digits together. If the digits added together are divisible by 3, the whole number is divisible by 3 from our divisibility rules. And so I know that 231 is divisible by 3. I'm going to go ahead and do that division problem. And I get 77. So with that 77, I can rewrite 231 as the square root of 3 times 77. Now 77 isn't prime either. It's divisible by 11. So I can rewrite that as the square root of 3 times 7 times 11. Now notice there's nothing squared in here. So I can't actually take out any numbers. They all have to stay inside that square root. So the simplest form for this radical is actually just how it started, the square root of 231, even though it's not a prime number. Sometimes you don't have two factors that you can take out one from under the square root. Radical. And now for our last radical simplification, we have the square root of 108. Now because I memorized my 12 times tables, I know that this is 12 times 9. I know a lot of you have not memorized your 12 times tables. We had to do that when I was in 3rd grade, so I see that right away. Now I can rewrite that in more factors. 12 is the same as 4 times 3, and 9 is the same as 3 times 3. Now it's still not simplified all the way down, so I can rewrite that 4 in terms of primes, 2 times 2, and then I have 3 times 3 times 3. Now I can write that with squares. That's what I really want to do. So that's the same as 2 squared, and I'm going to write a 3 squared, and then I'm going to leave that extra 3 in there. Now that's the same as, I'm going to split these into their parts there, the square root of 2 squared times the square root of 3 squared times the square root of 3. And now I can take the square root of something squared, and there it's 2, and then 3, and then I have a square root of 3 left over. I'm going to go ahead and do that multiplication. 2 times 3 is 6, times the square root of 3, and remember I don't have to write that times sign, so it's just 6 square root of 3. Now let's say I didn't recognize that as my 12 times tables, and I knew it was an even number, so I knew it had to be divisible by 2 or have a factor of 2. So I can go ahead and do that division. 2 goes into 108 54 times. And so the square root of 108 is the same thing as 2 times 54, the square root of 2 times 54. And 54 I know is an even number, so I can divide that by 2, and I get 27. And so instead of 54 right there, I'm going to put 2 times 27. So I have that 2 from the other one, and then 50, instead of 54, I put 27 times 2, or 2 times 27, either way. And then I know 27 is the same as 3 times 9. So I can write that. And then I still have that 2 from before. And I'm still not down to prime numbers yet, but I do see 2 2's. So that's 2 times 3. 9 is the same as 3 times 3, and then times 2. And I'm going to see if I can make anything squared, so the square root can undo that. All these numbers in here, if I were to multiply them, I would get back to 108. It's the same thing. I'm just writing them in terms of their prime, in terms of its prime factor. So I have 2 2's, so I write that as 2 squared. I have 3 3's, but I'm going to write 3 squared times 3 so that I can take out the 3, or I can undo the squared of the 3. So that's the same as the square root of 2 squared times the square root of 3 squared times the square root of 3. The square root of 2 squared is 2. The square root of 3 squared is 3. And that's times the square root of 3. I can multiply the numbers outside my radical as 6. 6 times the square root of 3, and it's the